So what a lot of people are trying to figure out today for the Internet of Things is how can I collect all this data? How can I make something useful out of it? But what all that is predicated on is, can I trust the data in the first place? Because if you can't trust your data, then there's no point in going and analyzing it and trying to make a business decision based off of it. So that problem comes down to authentication. How do I know that a particular device that I'm pulling data from is a valid device, one that I recognize, that it's in a secure state, and that I can trust the data coming from it? So the business that Thales has been in for a long time is the credentialing of devices using things like PKI and digital certificates so that you can have a basis, a root of trust from which you can say, yes, I do recognize that device, I own it, it's in a secure state, and I'm good to collect data from it. One of the great ways to do that is at the time of manufacture to be able to insert credentials into that device. And people will use Thales HSMs to create keys, use their PKI to generate digital certificates from it, and then inject those into the device. Now you've got a means by which you can authenticate it, and a means by which you can establish session keys and the like to collect data from it in a secure way. So HSMs provide a very critical piece of key generation to enable that process. Also, you have to worry about, once you've collected all the data, how do you protect it? But how do you protect it in a way that doesn't get in the way of the analytics on the data? So things like parametric transparent encryption can go a long way toward providing you security for your data, but yet not get in the way of analytics. There's also a lot of concern about anonymizing data. So if you're collecting data from a healthcare device, for example, you might want to anonymize certain pieces of that data before it goes into your IoT platform and your analytics engine. And those are the type of things you can do with the parametric solutions. Another piece is code signing. So we all saw with the Mirai botnet the issue of somebody being able to load malware onto a device, take it over and do something else with it. One of our key solutions is code signing that'll allow you to make sure that when you're sending a piece of firmware down to a device, either a firmware update or a security update, that you know the authentic source of that code is coming from you, that it's not a code update coming from somewhere else. And that's what code signing with HSM protected private keys can help you accomplish. And that's a business we've been in a long time and translates very well into some of the issues around unprotected devices in the IoT. So one of our most common use cases over time has been the credentialing of devices. Long before it was pretty cool to call it IoT, we've actually been doing that for device manufacturers. One of the big reasons was to prevent counterfeiting. So people that produce devices, Polycom is one of our longtime customers, and their goal was to be able to control the manufacturing process around their phones and ensure that manufacturing lines that were not in their direct control might be run to produce extra devices that might eventually be sold on the black market. So they implemented a process where they would generate keys and certificates and authorize a certain amount of phones to be produced on their manufacturing lines. And they leveraged Thales HSMs for that. And then going forward, you can imagine that model translating to many new types of devices. Again, for the problem of protecting the manufacturing process, but also so that a customer, when they first start to use the device, can have confidence that it is a valid device and use that root of trust that's embedded in there to then be able to securely communicate with the device for future uses.